Okay, kiddos, now we're moving on to our next lesson, which is 1.5, talking all about angles. Okay, so you've heard about angles before. Angles are something that looks just like this right over here, right? That's an angle. So, what's our definition? Okay, an angle is it's a set of points consisting of two different rays that have the same endpoint. Okay, so two different rays with the same endpoint called the vertex. Okay, so that set of that center is called the vertex. So if we look right over here, this is a ray, right? This is a ray AC, right? Because it starts with A, right? And then goes to C, and then we're going to use that arrow, right? We're going to say we always start with the end point. Okay? What's the other side? The other side is this right here, so I'm going to put that in a different color, right? So that's going to be ray AB, right? Ray AB. Okay, because we start with A first, right? The vertex, we said, is the same endpoint. So this right here is the vertex. So that's going to be the vertex is called A, right? So that's our vertex. Okay, so if this is one ray, that's another ray. This makes this angle. Now, when we name an angle, we could do it many different ways. All right. So the first way is by using its vertex. Okay, so the first way is the vertex. The second way is using a point on each ray and the vertex. Okay, and the vertex is always in the middle. Okay, or number three, we can use a number. Okay, so let's take a look right over here. First way we said, let's name this right over here. Okay, so the first way we said is using the vertex. So let's do that with a number one. Okay, so the first way is with the vertex. We said the vertex is the common endpoint. So this one we would call angle A. So we're going to use this symbol right here. So we're going to use, this is called an angle. We're going to use this symbol right here. Okay, so keeping that in mind, let's call this angle A. Okay, so we're going to say angle A. Okay, so that's one way we can call it. All right, next we said we can use a point on each ray and the vertex. Okay, so C A B. We said the vertex goes in the middle. So C A B. So the second way is angle CAB, or we can also go the other way, right? Because this is the same angle. BAC, with the middle always being the vertex. So CAB and BAC. Okay, so B, angle BAC. Okay, then the third way is if there's a number. So if we see this right over here, this is angle 1 because it's at the vertex. This is at the vertex, so we can call that angle 1. All right, so that's how we name it. Name it by either using the vertex, a point on each ray, and the vertex with the middle being the vertex, or by a number. All right, now let's classify it. Here's how we classify angles. So this first one right over here, right? This one is less than 90 degrees. Okay, and where we look at it is right over here for the measurement. Okay, from one ray to the other, in between is the measurement. Okay, so this is the measurement right here. It's less than 90 degrees, and we call that acute. Okay, so that's called an acute angle. Okay, so similarly, if we look at this one right over here, okay, this square right over here, okay, this one tells us that it equals 90 degrees. Okay, and this is a right angle. Okay, anytime we see it just like that, where it looks like it's a corner, we're going to know it's 90 if it has that. So if it has symbol, if it has this symbol. Otherwise, we're just guessing. Okay, so it has to have that symbol. All right, next, we said acute is less than 90. On this one, if we notice how much it opens, okay, if this is 90, it's more, right? We're going to say this is more than 90 degrees. So we're going to call that obtuse. Okay, and then this one's a little bit trickier. If you notice, it looks like a straight line, right? The angle, if we imagine something like right here, the angle would go all the way from here all the way to there, right? So this one equals 180 degrees. Okay, that equals 180 degrees. We can kind of draw it just like that, right? And then we're going to call that a straight angle. Straight angle. Okay, so if it's less than 90, it's called an acute angle. If it's exactly 90, it equals 90, because we see that, it's called a right angle. If it's more than 90, it's going to be called obtuse. If it's a straight line, it's going to be called straight. Okay, so those are the four types of angles. So what would you classify this angle right over here? Okay, that's right. On this one, we would classify this one as an acute angle. Okay, now this last part says something is in the interior of the angle. Interior means inside, so this is called point D. Okay, so that's just bringing in what we've talked about earlier, right? A point is just a point. Okay, so this is a ray where it has an end point and keeps going, right? That's called a ray. So ray AC and ray AB make this angle. We can call this angle A, or angle CAB, or angle BAC, or angle 1, right? Because we see that 1 right over there. Okay, it is an acute angle because it's less than 90. All right, so let's get right into some further practice. Okay, let's look right over here. It says on number 1 and 2, write 3 names for the angles. Okay, so 3 names for each angle. So this angle number 1, remember we said the first way is by using its vertex. So the vertex is the corner. All right, so you can think of the vertex as being the corner, right? On this one, we said the vertex was A, right? So on this one, we would say the vertex is Q. So we can say angle. So using the first way, we'd say angle Q, right? All right, using the second procedure, right, we said using a point on each ray and the vertex with the vertex in the middle. So we could call this PQR or RQP, right? Angle PQR or angle RQP. Okay, so they wanted 3 different names. So that's 3 different names. Okay, so keeping that in mind, what about number 2? Okay, the first way on number 2 would be angle Y, right? Because we have this Y right over here. That's the vertex. The second way would be angle XYZ. XYZ, right? Or angle the other way, right? We can go XYZ, or we can go the other way, ZYX. ZYX, right? And then let's do one more way. What another way we could say is just angle 1. Angle 1. All right, so that's how we talked about naming those angles. So let's step it up. On number 3, it says name 3 different angles. 3 different angles. So let's highlight this one. How about this one is one angle, right? So we can call that, the first one we can call angle EFH. Or we can also call it what? HFE, right? It's the same angle, angle HFE. They're both the same angle. Okay, next, what's another one? Let's put a different color. What if I said in red, right? This is another one, right? And we go through E, F to G. Okay, so second one we can call angle EFG. Or what's another way of calling that same angle? Instead of EFG, I can call it GFE, right? GFE, angle GFE. Okay, and then the third angle, right? Let's change that to a blue color. Okay, so the third one, actually let's make it a green color. Third one, let's say like this one right here, right? That's another angle. So we can call that angle GFH. Angle GFH. Or what's another way of calling it? The other way, right? HFG. Angle HFG. All right, so we talked about we can name it either by the vertex, like Q, or going by the end rays, then the vertex, then that. So PQR or RQP. Same thing, XYZ or ZYX or angle 1 or angle Y. Now, can we name this angle F? What do you think? Can we name this F? And the answer is no, because it's not specific enough. Right? It's not specific enough because F, what do I mean? Is it this red one? Is it the green one? Or is it the blue one? Right? If we just say F, that's not enough. All right, so keeping that in mind, let's go on to our next part. We're going to talk about what congruent means. Okay, you've heard the word congruent. Congruent means when angles have the same measure. Okay, when they have the same measure, that's when they're called congruent. Okay, so here's how we know if they're congruent with this symbol. Equal angles, right, which have the same or equal measure. Okay, equal means the same thing as same. So if they have equal measure, they use the same arc marks. So this is an arc right over here. So these both have one hash mark on each, right? This one is right over here, right? So this angle is using that one hash mark. Okay, so now if I put a different color, for instance, this one right here is using also one. So since these have the same arc marks, right? This one has just one arc, and this one has just one arc. Okay, that means that it's equal angles. Okay, so the arcs are something like this. Okay, so if we have different arcs, they are different measures. They're not equal. So these are equal angles because they have equal marks. This one is different from this. So for instance, this is going from all the way from here to here, right? So that would be this purple one. Oh, right? That would be from here to here, right? That's one angle measure. But this other one right over here has two arcs, right? It has one there and one there. So this two arcs and the one arc are different measures. Okay? So if they have the same mark, they're going to be equal. If they have two different ones, they're different. Okay? Or if they have different ones, they're different. All right? So let's look over here. It says identify the angles congruent to ADG. Okay, so let's trace that out. ADG, right? And remember, congruent means equal measure. Okay? So on measure, right? Okay, so congruent to ADG. Angle ADG is using two hash marks, right? If we see that, two arcs. Okay, it's using two arcs. Okay, so the congruent ones will also have two marks. So this one right here just has one, right? That has one. This one has two. So let's name that one. Let's kind of draw it out. That's from P, E, and H. So we would say angle P, E, B, E, H, right? And then another one, right? We see this one. This one right here has two, right there also, right? That one has two, that has two, that has two. So that one we would call angle CFI. Okay, so congruent means that they have the same measure. For them to have the same measure, that means they have to have the same number of arcs, right? So this one right here has 2 arcs on that angle. That has 2, that has 2, so those are equal. This one has 1, and this one has 1, so those are actually both equal. Those are equal, those are equal, and they're equal to each other. All right, so let's go ahead and move on to our next page. All right, folks, let's get right into some practice then on this. So now let's kind of bring back what we've been talking about earlier, right? So on segment addition, that's very similar to what we're calling angle addition. So if we see this angle right over here, we can think part plus part equals whole. Okay, so if we see this whole angle right over here, okay, if I imagine that I say this is the first part, so this is part number 1, right? And if I say this is the second part, part number 2, okay, what if I colored those in, right? So let's say the first part is this right here, right? That angle. Okay, if the second part is right over here, that's going to equal the whole thing, right? So that's what we were going to remember from our practice from before, is that part plus part equals whole. Okay, so if P is in the interior of this, right, if that's in the middle, that means if it's part plus part equals whole, this first part, which is RSP, so angle RSP, plus the second part of PST, right, equals the whole thing of RST, right? So part plus part equals whole. Okay, so we can see that first part plus that second part equals the whole thing. Okay, so keeping that in mind, let's get right into some practice. Okay, so let's look at this one right over here. It wants us to find JKL. So JKL. Let's go and trace that out. JKL. So is that a part or a whole? That's our question. Okay, well, JKL is the whole thing, right? It's the whole thing. Okay, so if it's the whole thing, then we're just going to set it up. Part plus part equals whole. Okay, so that's our first setup. So we're going to say the whole thing is what they're looking for. So the whole thing, measurement of angle JKL, is equal to 31 plus 85. Right? So if this part plus this part equals the whole thing, right? So we're just going to type that into our calculator. That's going to give us 116 degrees. Okay, so the measurement of angle JKL is 116 degrees. So all we're doing is doing part plus part equals whole. Okay, so we're going to say that's like part number 1, and that's part number 2. Okay, so part plus part equals whole. So keeping that in mind, let's look at our next example right over here. Okay, so this one says if RSU is 91, find RST. So let's look, RSU, let's trace that out. RSU, R to S to U. What is that? Is that a part or the whole? That is the whole thing. The whole thing is 91. Find RST, which is a part. Okay, so if this is part number 1, that's part number 2. Let's set it up with part plus part equals whole. Okay, so the first part is this. We don't know what that is, right? So let's just put a X there for something we don't know yet. So X plus our second part is 69, right? Equals the whole thing. We said the whole thing is 91, right? So we're just going to subtract 69 from both sides, right? So that means carry classes out. X is going to be equal to 22 degrees. Okay, so we can just think 91 minus 69 gives us the answer of 22 degrees. All right, so we're just going to remember part plus part equals our whole amount. Okay, so now let's step it up. Okay, now let's bring in some algebra and some other ones, other information. So this says UWX is a straight angle. Okay, what does that mean, straight angle? That means it equals 180 degrees, right? That's what we talked about from the last page. All right, so it says UWX. Let's trace that out. UWX, right? And that makes sense. That's this right over here. It goes from U through W all the way to X. So that all adds to 180. Well, they want us to find UWV, so this and this, but they have variables. So what do? First thing we need to do is write an equation, right? So we're going to think part plus part equals whole. So the first part is x plus 10. X plus 20, right? Plus the second part is x equals, what did we say the whole thing is? The whole amount is a straight angle of 180. Okay, so we're just using the information that we have. Now, see if you can solve this on your own. And pause and unpause as you can to see how much you can do. All right, first step, we should have combined our like terms, right? We should draw our line down there. We should have combined. X and X would have given us 2X. And how did we get that? Well, because we know it's a 1X and a 1X, right? 1X plus 1X gives us that 2X, right? Now we're just going to bring down this plus 20 at the end, okay? Equals 180. And now hopefully it's getting even easier for you, right? We tell ourselves we're going to work with our variable term last, right? So we're going to add the opposite of that 20 to move it to the other side. Remember, anytime we want to cross the line, we have to change the sign, so we have to add the opposite. So going from left to right, we're going to bring down that 2x. Okay, these two opposites cancel out, equals 160. Okay, we know our last step is to always divide. X equals 80. Now, let's look how we can use that for our final answer, right? We're going to use that over here. Okay, so XWV. XWV is represented by X, right? So if that's equal to X, then that's equal to 80 degrees, right? Because that's what we said, X is equal to 80. Now let's look at UWV. I'm sorry, yeah, UWV, right? UWV is X plus 20, right? UWV is X plus 20. Well, what does that mean? That means in place of the X, right, I'm going to put 80. So that's going to mean that's equal to 80 plus 20, which is equal to 100. Okay, so once again, the reason why we do all this is to figure out what x is, and then we substitute it in, we evaluate, right? All right, let's keep it moving. Okay, let's look at our next style. Okay, well, what do we know about this one? If we notice, we don't want to overlook this. What do we see? We see that box right there, right? That tells us it's a right angle. Okay, and what does that say? That means it's 90 degrees, all right? So that's our little key hint right there, is that it's 90 degrees. So if they want us to find CAD, right, CAD is represented by a variable. That means we need to figure out what x is, right? Then they want us to find out BAD. BAD, it has a variable, so we got to figure out what x is. So we're thinking part plus part equals whole, right? Well, what do we know? We said this first part is that, right? So the first part would be is 5x plus 57. Plus the second part of x plus 15 equals the whole thing. What did we say the whole thing is? That's right. We said the whole thing is 90. Right? So now let's combine our like terms. So what do we get when we combine? Okay, the first thing you should have gotten was 6x, right? Because we have 5x plus that 1x, right? That would have given us 6x. All right, next, what do we have? That's right, we should have gotten plus 72 because we have 57 and 15. That gives us 72. Equals 90, right? Now we keep moving. Just like we've been talking about, we're going to work with that last. So we're going to add the opposite, 72, to both sides. Cancels out, so 6x equals 18. We know our last step is always divide. Divides out, x equals 3. Now remember, we're going to use that to get our final answer. They want CAD. CAD is represented by x plus 15, right? X plus 15. So that's going to be equal to 3 plus that 15, right? Okay, so that means our answer is 18. Okay, keeping it moving, BAD. BAD is represented by 5x plus 57, right? 5x plus 57. So that means in place of the x, I'm going to put our value of 3, right? That's where we get that from, is 3, right over there. Okay, so now that we can do that, we can just type that into our calculator, and that will give us the answer of 72, right? That'll give us 72. Now, one thing to keep in mind is we can do the math, right? We can say 15 plus 57 is 72, because I know a lot of y'all will like to do the math. But either way, we can just type it into our calculator. That gives us the answer. So the main thing on these is that we got to use our problem-solving skills. Is we got to think about what we know. Okay, on this one, we know that this one equals 90 because we see that. So part plus part equals 90. This one, part plus part equals 180. Right, so we know that. So now that's our part plus part equals whole. Now we're going into our last part. Okay, so this is, we can definitely do this, so let's stick with it. These should be relatively easy now that we understand a little bit more of our terms. So angle bisector. This is similar to a segment bisector. Remember, bisector means creates two equal parts. Okay, so we're going to remember part equals part, or part equals the whole thing divided by 2. Okay, so these are what we're going to remember. Part equals part, or part equals the whole thing divided by 2. Because the angle bisector is a ray that divides an angle into two angles that are congruent. We said that means equal. So if we look at right over here, okay, you can get this. I know this is a little tricky. If we see this right over here, this X, Y, Z, right? W is our angle bisector. It cuts it into two equal parts, right? Because since that has one arc and that's one arc, those are equal measures, right? Because they both have one arc. Okay, so let's talk about that. What did we say bisects this? We said ray YW, right? Ray YW bisects angle XYZ. So, which two angles are congruent? XYW and WYZ. Okay, so let me try to better explain that. What that means is if this cuts it, that means it creates this and this into an equal angle. Okay, so as we calculate this, is we're going to say if we start with the whole thing, we're just going to divide it by 2, and that will be each part. Or if we have the part, one part equals the other part. Okay, so keeping that in mind, let's look at some basic examples right over here. Okay, it says DEF is 92 degrees. DEF, so let's trace that out. DEF is the whole thing, right? That's the whole thing is 92. EG bisects DEF. So EG bisects it. So that makes 2 equal angles, right? So if they're both equal, it says find DEG and GEF. DEG and GEF. So that's going to be part number 1, right? And that'd be part number 2. Okay, so if they want to find those, we said the part equals the whole thing divided by 2, right? Part equals the whole thing divided by 2. So if that's the case, that means the part equals 92 divided by 2, which is equal to 46 degrees. So each part is 46 degrees. So that means angle DEG, right? DEG is 46 degrees. Angle GEF is 46 degrees also. Okay, and that makes sense, right? Because we said they should be equal parts, right? This part should be equal to that if it cuts in the middle, and 46 plus 46 equals 92. All right, so now let's step it up with some algebra. Okay, so if QR bisects PQS, so QR, right? This bisects it. That means that we have two equal parts, right? So this is going to be part number 1, and that'll be part number 2. So if we want to find PQR, PQR is represented by that, right? Well, if it's represented by that, that means I need to figure out what that is, right? If Q, then PQS, PQS, that's the whole thing, right? PQS is the whole thing. Okay, so if that's the whole thing, the way I can figure out the whole thing is if I know what one part is, then I just multiply it times 2 and I get the whole thing, right? Or I can say this part plus this part equals the whole thing. Okay, well, what do we know? We know that part equals part, right? Because if it's a bisector, we know this equals that. So once we can make an equation involving that, we can solve for x and we can figure those out, right? So let's set it up. Part equals part. So 4x minus 10 equals negative 3x plus 130. 4x minus 10 equals negative 3x plus 130. Okay, now let's just follow our steps, right? We're going to draw our line down there. We want to move this to the other side. Remember, if we cross the line, we got to change the sign. So it's going to be a positive 3x. Positive 3x cancels out, so 7x, bring down negative 10, cancels out 130. Right, now we're got to where we have a variable term and a constant on the same side. So we got to get rid of that constant by adding the opposite. Remember, if we're going to cross the line, you got to change the sign. So we can change that to a plus 10, plus 10. That's going to be 7x, cancels 140. Right, now we're ready for our last step on solving, right? We know our last step is divide. Divide by the same number that's in front, so that means x equals 20. Right, but let's use that for our information, right? We said PQR, PQR is 4x minus 10. 4x minus 10. So that means that's equal to 4 times the quantity of 20, right, minus 10. So that's going to give us 70. And the way we find that out is 4 times 20, right, is 80. Minus 10 gives us 70. Okay, now PQS. PQS is the whole thing, right? So we know the whole thing is the part times 2. Right? So that's going to be equal to 70 times 2. We can do it like that, 70 times 2, which is equal to 140. Okay, so once we recognize that we know one part and the other part equals the whole thing, if the parts are equal, that means we just add those up. All right, so I know we can do this. The main thing is we got to recognize if we're doing part plus part, part equals part, or part plus part equals whole.